Now we're going to look at factoring, some examples that are a little more complicated than those we've done in earlier lessons. The first example we're going to look at involves both a greatest common factor and a trinomial. And our problem is to factor 2m cubed minus 4m squared minus 6m. When we do problems like this, or any factoring problem, we always want to look for a greatest common factor first. That's our first step. So looking at this, we have a 2 that's in common, so we can pull out a 2. We also have the variable m. So taking out a 2m, we're going to be left with m squared minus 2m minus 3. And now we want to look at what's in the parentheses again. Is there any greatest common factor left? Well, no. So then we'll say, is that a candidate for grouping? Well, the hot tips for grouping are having 4 terms, and then you can find common factors if you look 2 by 2. We only have 3 terms. Not a candidate for grouping. So then we'll look, is it a trinomial? And it is, and it's got that pattern, m squared, m, and then we don't have any m at all. So this is a trinomial. Our next step after that would be looking for difference of squares, but we'll stop here on this problem. We want to figure out now our product and our sum for our table. Our product is the negative 3 times the coefficient of m squared, which is just a 1, so our product is negative 3. Our sum is the coefficient of the middle term, or negative 2. So we're looking for factors of negative 3 that add to negative 2. And since it's 3, we don't have a whole lot of choices. We have 1 and 3. And it's just a matter of deciding where the negative sign belongs. Well, if we want these to add to negative 2, we should have a negative sign on the 3. So we have a 1 times a negative 3, and that adds up to a negative 2. So these are our factors that we're working with, or rather the numbers we want to work with. Now, since this is a special case, we just have 1m squared, we can go ahead and move right to the factored form. We'll have our m in each factor, and then we'll just put these numbers from our table right into our factored forms as m plus 1 and m minus 3. They take their signs with them. And this is our factored form. Now we can have a more entertaining example yet. And we'll go to one. Let's take a trinomial in the form ax squared plus bxy plus cy squared. So we still have that pattern. We've got x squared, x, and then no x at all. And we can look backwards. We have y squared, y, no y at all. So this is a trinomial. But now we've got 2 variables we're working with. And the example I want to factor here is 12n squared plus 59nb plus 72b squared. When we factor this, we're going to end up with something multiplying an n plus something times b, and then we've got another blank with n and another blank with b. And the trick is to figure out what goes in those blanks. What coefficients do we need in here? So our first move again is to look for a greatest common factor. Let me just rewrite the 12n squared plus 59nb plus 72b squared. And there is none. So those numbers are not going to get any smaller for us, and we don't have any variables in common. Since there is no greatest common factor, we move to grouping. Well, not a candidate for grouping. I only have 3 terms. Trinomial. It is a trinomial, and so we need to deal with that product sum table. These are large numbers. I'm going to cover this up for a moment and work with those numbers. Our product is going to be the 12 times the 72. And this ends up as 864. I am not interested in finding all the factors of 864. That's a large number. And anytime my product gets up in the hundreds, I take what works as a little shortcut for me. I try to streamline the process by writing a factor tree. I know 12 is going to go as 3 times 4. 72, we can go 9 times 8. So let's see, 4 is 2 times 2. 9 is 3 times 3. And because I've worked with it a lot, 8 is 2 times 2 times 2. So when I work with my product sum table, I'm just interested in combinations of these 3's and 2's here. So I have 2 times 2 times 2, 5 2's, and 3 times 3 times 3. And I want to try different combinations of those. So I could just say, all right then, 2 times 2 times 2 times 2, that's a 16. And here we've got 27 times 2. Well, let's see, 27 times 2, 14, 54. 54, and I want to check, do those add up to my sum of 59? Well, no, that's 70. Not quite what I want. So I'll try something else. I could try, what if I just grouped all the 2's together? Well, 2 to the 5th power is 32. And then 3 cubed is 27. So I better check that. 32 times 27 is 14. 21, 22, and 4, and 6. Make sure I haven't left anything out. 4, 6, 8. So I've got my 864. I can add them up. 32, 27, there's a 9, 59. So this is it, 32 and 27. And, you know, this is a good way to use scratch paper. Just have one for your factoring. So I'm interested in 32 and 27 for the product side of my product sum table. Sum comes out to be 59. So all is right with the world. I'm going to go ahead and rename the middle term. So we have 12n squared plus 32nb plus 27nb plus 72b squared. And now I'll use factoring by grouping on this piece. Going 2 by 2, let's see, 12 and 32. I can take out a 4, and there's an n, leaving me with 3n plus 8b. 27 and 72, we've got a 9 in there. And then we've got the b. So pulling out the b, we're left with 3n plus 8b. And you have to force yourself to work through this independently. The insides of the parentheses are exactly the same, so I can be pretty certain that this is correct. And now I can factor out the common binomial, 3n plus 8b, leaving me with 4n plus 9b. Now to check this, I should go ahead and FOIL this entire problem out. And you will find, if you try that, that it does match the original problem statement, the 12n squared plus 59nb plus 72b squared. If you have any more questions on factoring problems that have more than one type of factoring involved, like the greatest common factor and the trinomial, or the more complicated trinomials, go to the Polya Center, ask a tutor, see your focus group leader, get a study partner, and work on some more problems.